Good afternoon, everybody, and welcome to this webinar arranged by the South African National Group of IABSE. My name is Pierre van der Spuy, and I chair the national group, and I'll be the moderator for today's session. Please note that the session is being recorded, and it will be distributed on all IABSE social media platforms. And if you want to ask any questions during the presentation, please post them in the Q&A box, and we'll attend to them at the end of the presentation. So with me here, I've got Wium, also from South African National Group, and also Rudolf who will be our presenter for today. So I'm going to hand over first to Jan to give us a bit of a background to IABSE. Mostly for those that aren't IABSE members, please become a member. But Jan will give us some background. Thanks, Jan.
Thank you, Pierre. Let me just get my screen shared with the audience. How should I do that? Oops. I thought I've got it all under control, but it doesn't seem so. There, share. Okay, and then increase this. All right, I think by now you see my screen. It's a good afternoon. To me, it's afternoon. For those of you who are not in our same timeline, good day to you. I'm going to say a few words about IABSE, the International Association for Bridge and Structural Engineering. So IABSE's mission is basically to exchange knowledge and to advance the practice of structural engineering worldwide. It covers all structural engineering aspects, as well as all structures and materials, and all construction processes. As you can see, there are more than 100 countries represented at IABSE. So it was created in 1929. The association is almost 100 years old. And IABSE deals with all aspects of structural engineering, the science and art of planning, design, construction, rehabilitation, and so on. You can read that paragraph. But it's important to note that the last sentence there, the term structures includes bridges, buildings, and all types of civil engineering structures. So often people think International Association for Bridge and Structural Engineering, they often think it's for bridge engineers only, but it covers all aspects of civil engineering structures. The president of IABSE has a 3-year term. So Tina Wium of Denmark is the current president, and the new president-elect for the coming 3 years from 2025 onwards is Harsha Subaru, is from India. All right, so IABSE has the following objectives: is to promote cooperation and understanding amongst all of those who have structural engineering as a passion. Important is that it encourages awareness of structural engineers towards the needs of society. It encourages actions for progression or progress in structural engineering. And then it's there to improve and foster cooperation and collaboration, not only between organizations, but also between individuals. So the organization organizes conferences, publishes journals and books. I'll tell you a little bit more about some of the technical groups, and then there are national groups such as ours that also arrange events. And then there's also annual awards. So one of the main items or activities of IABSE is the annual conferences. This year there was one in South America. In May next year of 2025, there will be a symposium in Tokyo in May. And then the main conference of the year will be in Ghent in Belgium in August of next year. Important to note that there's still some opportunity to submit abstracts for this conference. It closes on the 15th of November. And maybe I can add that if you're not an IABSE member or maybe an early member, these conferences are actually the place where you really get to know one another and the organization. And from the first time I went to a conference such as this, I realized that there are other people who share the same passions as me, and where you interact with others, well-known names, not so well-known names, would be well-known names, and people who are really have just the same passions than yourself for structural engineering. So make a plan, make a point of it to get to one of these conferences, and you will find that there's a whole new world that opens up for you. There are webinars such as we have today, which are recorded and one can re-listen to them. Then another flagship of the organization is the journal, the Structural Engineering International, which is a high quality journal, but there are also other documents, bulletins, books, and conference proceedings. These can all be obtained from the head office in Zurich. The national groups are actually the vehicle through which many of the activities are organized. The national groups have an annual meeting at the conference towards August next year then, where national groups meet one another, discuss what they do, and also collaborate on those platforms. So typically national groups would host seminars, workshops, site visits. They often do something for young engineers, and it's actually at this level where people start collaborating. But for me, the real benefit of IABSE has always been its international character. Quite a valuable contribution that IABSE is making recently for the past 5-6 years is the creation of task groups. So the task groups normally are allocated to one of these 6 technical commissions. I'm not going to go through that. You see the wording there. But a task group is essentially a group of people that get together that want to accomplish some aim. They want to publish something, or they want to publish a standard or a specification, or a book on footbridges, for example. Anything that you feel will make a contribution towards structural engineering, anybody can create a task group. If you can't find one that already exists, anybody is welcome to create one. Normally, the chair of such a group is an IABSE member, but non-members can also be members of such a task group. But the main thing with a task group is got a purpose and a deadline, a milestone by when they would like to achieve that purpose. There's also a space for young engineers. Young engineers meet normally independently some evenings and days during the conferences. There are also national groups that have got activities for young engineers, and there are certain benefits for young engineers with reduced conference fees and so on. Just before I go to the next slide, I remember I've neglected when I spoke about task groups, is that there's also a task group for building information models, looking at management aspects using building information models. So seeing that that's our topic of this afternoon, there may be some members of the audience who may be interested in that task group. So look out for that. On our webpage, there will be information about that. All right, so apart from young engineers, there's also activities for students with specific student membership. It allows them access to the high-level journal that we've got, reduced fees. And the big thing is that when students also attend conferences, you can interact with would-be employers one day. And I must say, if I was a young student or a young engineer 40 years ago, and I would have known that I could meet people from various branches of the industry around the world, I would have certainly have started attending these conferences. That's where you meet those people working on the type of things that you always wanted to work on when you grew up. But Pierre, thank you. That's my overview of the association. I'm handing back to you. It's the end of my slideshow.
Thank you, Jan. So now we go over to our main presentation, and I've briefly introduced our speaker, Rudolf, who will be talking about BIM in facade design today. Just a little bit of background. So Rudolf graduated in 2008 and 2010, both with distinction as one of Jan's students, and started working for Arab in South Africa. Rudolf, I think so. Yeah. Started working for Arab in South Africa, and has since started his own business, Roux Engineering, specializing in facade design. So without further ado, Rudolf, I'll hand over to you. Thank you.
Thank you, Pierre, for that introduction. I trust you can see my PowerPoint.
Yes,
And-
yes, we can.
Great. And I want to thank IABSE for this opportunity. And thanks to each and every one of you for taking time out of your afternoon to attend this talk. We'll be discussing BIM in facade engineering, or like we all know, it's building information modeling. I think you will see that BIM in facade engineering is perhaps a little bit different from BIM in other disciplines such as architecture and structural mechanical engineering. I hope that this talk will inspire you to find innovative applications to the problems that you are faced with. I will be showing you how BIM is conventionally used in facade engineering in more of a 2D application, then moving on to two geometrically complex projects that I was privileged to have worked on at Arab. I will show you the workflows that we used and discuss the challenges that we were faced with in those workflows and the lessons learned from those. And then I will move on to what I've been working on for the last 4 or 5 years, a tool that really strives to address those issues and bring BIM together into one centralized model for facade engineering and really addressing all of the needs of a facade fabricator. When we talk about facades, I will be specifically focusing on unitized facades. So there are different types of facades, but unitized facades by far are the most common. In our work, you get different types, but this one works on the principle that you have brackets that are installed on the slab edges, and then you have a hoist on the floor, and the unitized panels are loaded on the floor below typically, and then that hoist lifts the panel up and hooks it onto the brackets. And so the whole installation is really simplified. The manufacturing and quality control is mostly focused in the factory. Those panels have profiles all around the perimeter that interlock with each other with a double gasket type interlock. In the vertical, you have female and male half mullions, and on the top and bottom, you have a gutter and sill that interlock. Now, if there's one thing that you can learn about facade engineering, it's that we install panels typically from left to right. And in this panel, the female comes before the male. So that's easy to remember. And then also this panel that's already installed has a male mullion on this side, and that male mullion has to wait for his female to arrive. So yeah, if you haven't learned anything else, then at least that is what you can take away from this talk today. Conventional BIM in facade engineering, I will be looking at a case study of 144 Oxford in Rosebank that I did at Arab. So if you look at this building, how we would approach BIM is that, first of all, we would, in the shop drawings, we would have elevation, section, and plan drawings. And this is a typical elevation that you can see of that building. And that was done completely in AutoCAD, completely manually, taking the architect's drawing and redrawing the elevation and the sections and the plans. And on this specific project, we did have a 3D wireframe, but that was also CAD based. Then we would have detail drawings as part of the shop drawing set. And those are typically just 2D details with specifications on, and there are sometimes that you need to elaborate and look at that in 3D. But once again, this is all completely manually done in an AutoCAD environment, extruding profiles and annotating shop drawings. In this specific drawing, the complexity that we're looking at here is how to handle differential structural deflection of the floor slabs and how that is all accommodated within the facade framing. This is all submitted to the professional team for review, for approval. Once it's all approved, it gets issued for construction. The next step in this whole BIM process that the professional team does not see are the fabrication drawings. So this is a typical curtain wall elevation, and you can see that the draftsman has gone and allocated panel IDs So on the top left, you'll see N040101, then N040102, and that then repeats until we get to N040103, and so on. And now this is a completely manual process of looking at the elevation, thinking about what is the framing surrounding this, what are the dimensions, what are the glass types, and based on that, allocating numbers. And then if you look at that panel that's highlighted in red, that panel is then drawn out in detail for the factory. Now that in that process, you can use something like Tekla or AutoCAD. Mostly use Tekla for more complex shapes. And that is then taken for fabrication. The next set of drawings would be setting out or bracket drawings. And these bracket layouts are sent directly to site, just for the guys on site to know where to put the brackets. So if we look at that process in a diagram format, you've got a first process step that I've numbered 1. It's shop drawings, like I showed you, elevation, section, plan drawings, and detail drawings. These are submitted to the professional team for review. Once that is reviewed, it is then issued to site. A completely separate process, fabrication drawings. We've got the panel types that need to be identified and setting out and bracket drawings, and that is issued directly to site. And then there's the third step, the fabrication drawings, the panel details, and that is issued to the factory for manufacturing, and then those panels are sent to site. Now, what happens if the professional team, the architect, has a bright idea? Well, that has to travel through the shop drawing process and get resubmitted, and then manually steps 2 and 3 have to be updated to take account of those changes. And that's where an opportunity for mistakes definitely lie. So that is BIM in the conventional sense. It is mostly 2-dimensional, somewhat 3-dimensional, but there's no central model that contain any data, any information. It is a completely 2-dimensional process. Now we come to a geometrically complex project. PwC was a tremendous opportunity to work on, geometrically complex and complex in so many different ways, so many interesting challenges that we faced with the structural analysis. There was solar concentration analysis of the facade. We looked at the blinds, integrating different options of blinds into the facade. So yeah, a very interesting project. And on this project, we used Rhino. Rhino is a 3D CAD type software. And what you see there are individual glass surfaces modeled in Rhino. And this really comes out of a parametric type approach where we used a software called Grasshopper as a plug into Rhino to generate the shapes. Then those were exported to a format, SAT format, and imported into Revit as a mass. And then in Revit, you can fit curtain wall panels to those mass surfaces. Now, this is a very well-known workflow. If you just Google workflow Rhino to Revit, at least back then, there are many other types of workflows right now, but that was a very well-known workflow. Now, that Revit model, if you look at the typical panel, looked something like this. It had a glass panel and half mullions or half profiles around the perimeter. And you can see on the right-hand side there, it is relatively crude. If you look at the actual mullion detail, there's a lot of information that gets lost in that. But it provides a powerful 3D model that you can use to generate elevations, 3D plans, and 2D plans, and even some sections. And on those sections, you can call out details. Right, so that's what we used Revit for. And then we used something like 2D CAD to draw details. And just remember that all of these things are in some way disconnected from each other. Now, if we move on to phases 2 and 3, the more behind the scenes application side of things, we exported the Rhino information to AutoCAD. If you zoom in on this, you will see lines that represent the center line, the setting out line, that's mullion SO, mullion setting out. stack joints setting out, brackets setting out, transom setting out. So each and every component has a setting outline and an orientation. And on the right-hand side, you see the profiles of the system. So the draftsman would then take those profiles, insert them into the 3D and extrude along those lines. And he did that in Tekla. And so you can see that the middle part of the building is missing. That's just because those floors at the bottom can be repeated to get to the top. But yeah, that was the process that we followed. Just to note that in Tekla, you would have to do all that extrusion, and when the profiles come together, you would have to make sure that the miters are correct, that the profiles are meeting each other correctly. And then he was able to produce these sort of drawings that a poor guy in the factory has to look at and try and put this thing together. But that's the whole process. Then we got to work on the Marc Jewel in Sandton. Now, this is also an incredibly challenging project, a lot of fun to work on. And we followed the same type of process. We had individual glass surfaces in Rhino that then got exported to BMS in Revit, and then curtain wall panels were fitted to those. So that part of the process was the same. It produced elevation and plan drawings. That's really as far as you could take the Revit side of things. On the fabrication side, we had to produce these types of drawings once again. And so we could follow the same process as on PwC, just provide the wireframe and the profiles, and the draftsman would have to insert those profiles on the wireframe and extrude them. The problem is that there's almost no repetition within this geometry, and so those intersections where the profiles come together are a lot of effort to go through and miter. So then I learned of a plugin. So I told you about Rhino and Grasshopper. Grasshopper is the parametric plugin into Rhino. Then there was a plugin within Grasshopper that then could link your model directly through to Tekla. So I thought, well, let's give this a shot. The advantage of Tekla is that Tekla can almost automatically miter profiles where they come together. So this is a video of this process. You'll see on the right-hand side the framework in Rhino. In the middle, you see the Grasshopper script. And then on the left is Tekla. And you'll see what's happening is that that framing is transferred through into Tekla. The profiles are being extruded, and as they are extruded, Tekla is automatically doing all of that mitering. Still a lot of work left for the draftsman once he has the Tekla model, but I feel like a significant portion of the work is definitely taken off his plate by automatically mitering the profiles where they come together. Just a note on this project that we made no mistakes. There wasn't a piece of glass that didn't fit or had to be wasted or thrown away in any way. So you can see when you zoom in how the profiles come together. Most of the mitering is done, but you will see that some of where the panels meet, they don't know about each other. The panels don't know about what panels next to them. And so there's still a clash there that the draftsman had to clear. So yeah, that was PwC and the Jewel. So what's the problem with that? Well, the problem is that the workflows are separate. You require a transfer of model data between many different formats, and in many cases, you require manual updating of details and dimensions. So when there's a change in one, there's a manual process of transferring that information to the other one. So the question is there a workflow that can stay within one software environment, reference one model, and encompass all three processes? I will now show you the final result on an example building. This is a building I'm currently working on, Ingress Building 3 in Midrand. So what if we start with the building? It's a very simple building. It only has 5 curtain walls. And what we have in a 3D CAD environment are floor levels. Those are just lines. We've got grid lines. Each one of those grid lines has a little identifier with it, just like the floor levels. Curtain wall base surfaces. Those are surfaces that tell you where the curtain wall is. And each one has a little ID also on the surface in the 3D model. Stack joints, that defines where that surface will be split into panels, and mullion centers, once again, to split the surface. And in this specific case, we have some fins, the mullions as well. We also give some input on panel types. So what you see at the bottom there are the different panel types that are required, and they are shown in color by surfaces in the same place as the curtain wall base surfaces. Glass types, S1, V1, L1, they are defined in CAD files. Each panel has its own CAD file. And V1 is just Vision 1, and S1 is Spandrel 1, L1 is Lewis. And we just create a CAD file for each of those. Then there are some spreadsheets in which we define properties of the curtain walls 1 through to 5. I'm not going to go into detail, just to show you these. We are then also able to bring in from Revit the architectural and structural components in concrete, steel, and brick mostly. We can also do access floors and ceilings and so on. So there you see the complete model. And then this tool is able to look at those curtain wall panels and identify unique panels. And that is important because you want to have as much repetition as you possibly can. You don't want to leave that up to a draftsman to decide. And there's the final product. We just zoom in on that. You can see the glass hatches have been applied according to a preset list of hatch patterns. Each profile has been extruded. Each glass panel is there in full detail, already cut to size. And if you look in plan, we can generate elevation, section, and plan drawings, also completely automated. If you zoom in on that, everything you see is automated. The brickwork has been hatched to a brick hatch, concrete's been hatched to a concrete hatch pattern. And those little white red dots are the setting out points that can then easily be dimensioned. And that's the final drawing, sections, plans, and elevations. It's just been dimensioned and notes and detail numbers have been added. And since we have this detailed model with panel types and all of this data in it, we can generate panel types. And those are 50 unique panel types that the software identified. And if you look at each one of those, it is a fabrication drawing that is almost ready to be fabricated, but the draftsman can take this and add dimensions and notes and so on. We also can export the data from the model. So we know we've got a unique ID for each panel, and we know, for instance, if we look at U5, that there are 20 of that panel. And this is glass type. So we look at Vision 1 of that panel is 2460 by 1145. This is the cut size. So it makes it easy to order your glass. And the same goes for aluminium. For each panel type, we have mullion right, mullion left. Profile, is it a mullion, female mullion or a male mullion, and the length and the number of. So how do they get to this tool? First of all, I need to give you a little bit of just a background on Rhino and Grasshopper. Like I said, Rhino is a 3D CAD environment, and Grasshopper is a plugin that's more of a graphic programming language. So if we look at what we're seeing now, there's a square in the Rhino interface, that red square, and a little geometry icon in Grasshopper. That represents that square. Important to note that this square does not actually exist in Rhino. It is just a preview of what is actually in Grasshopper. I'll get to that in a moment. We can then create a series. We say we wanted to start at 7, and it must count up to, start at 1 and count up to 7. There you can see 1 to 7, that's the output of that component. Create a parameter called degrees, set to 2.2 degrees, convert that to radians, multiply the series of 1 to 7 with that, and this is a series of radians. Let's take a factor of 4000 4,000 millimeters. Let's say that's a floor height. Plug that into a Z vector, and out you get 0, 0, 4,000, 0, 0, 8,000, and so on for all 7 of those. Now, what we can do is we can take our square and plug that into that move component. And you can see in Rhino, we now have moved that the 7 times. And we can rotate it. And that is essentially a little PwC tower being created right there. And as we play with those input parameters, we can get different results. So it's a great tool for experimenting with different options. Now, the concern with this, the difficulty with working with this, is that everything you've seen now only exists within that grasshopper file. It does not exist within Rhino. If you want that specific solution you came up with now to be in Rhino, you can, what they call bake, you bake it into Rhino. It is then in Rhino. If you then change it and you rebake, it does not delete the previous one. So you rebake and you can get duplicate geometries, right? So you really want to stay within Grasshopper if you want to re-reference something that you've created before. And that's where you end up with a Grasshopper file that looks like this. And this was the final PwC Grasshopper file. Yeah, so you can see there are wires that go from one block of code through to another block of code, and that gets reused in another block of code. And I mean, if you're not working on this every day in and out, it's going to be a nightmare to decipher. I think I recall this orange one was structural steel components, and I can't even remember the rest. But the reason this looks so complicated is because something I created in one script, I wanted to reuse it in another one. And so I just had to link it, and you get all these incredible wires. Thankfully, someone came up with a solution for that. Front Ink, you can look them up online. There's this webinar on Vimeo that you're welcome to look up. They worked on this Morpheus Hotel, and they had to create all of those little wires that go around the facade. And they wanted to do it in Rhino, and they had a large team of people working on that. They needed a lot of people accessing the same model at the same time, but not conflicting. And so they came up with, they came up with this tool called Elephant. And those photos just show you some of the complexity of those components that they had to work on. Now, how does Elephant work? What does Elephant do? Very simply, first of all, Elephant is a plugin to Grasshopper. You can use Elephant to reference geometry from Rhino and then filter that geometry based on its attributes and then process that just like you would in any other Grasshopper environment. For that, you use traditional Grasshopper, and then you bake back into Rhino with Elephant. And in that bake, you specify a bake name. And what Elephant would do when it bakes is it would first find all the components with that bake name in Rhino and delete it, and then rewrite with that same bake name. So you never get duplicate data. So if you have a component, you reference it, you filter it, you process it, you send it back to Rhino, you'll still just have one component within Rhino. So you can have one process like this and then repeat it in another process and repeat and repeat and repeat. So back in 2020, just as I've been wanting to do this for a long time, but then we got COVID. We had lockdown for, I think initially it was 3 weeks or 2 weeks, I can't remember, but I was just fortunate enough to have this to do. So I dreamt up this little fake building and I started coding. And you can see on the right hand side there's some of the Grasshopper script, and it's neatly broken down into individual components. So if you just zoom in on that to 3 of those components, what I would do is I would reference, filter, process, bake, and just repeat and repeat. And you can see I've added notes what each component does. This one splits the curtain wall base surfaces into curtain wall panels. Then the next step would be assign floor properties to the curtain wall panels. Then assign row, index, and panel ID to the curtain wall panels. So in this setup, I would have to go to the reference part, click update, 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 go to the bake, click bake, go to the next one, click update, 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 go to the right hand side, click bake, and so on. I'd have to go through this process one by one. And then just at that time, Rhino 7 was released, and Rhino 7 came with this wonderful tool called Grasshopper Player. And what Grasshopper Player allows you to do is to not even open Grasshopper, just have your Grasshopper script somewhere and say, I want to play that Grasshopper file, and here's some of the inputs to that Grasshopper file. And so now I'm able to take that one big Grasshopper file and split it into individual files and just play. And the beauty of that is you can put that into a macro. And so there's a macro that pulls all of these Grasshopper files one by one. And I'll now demonstrate the running of that on this project to you. At the top, you can see the macro components running through the command prompt. Panels, the curtain wall surface gets split. There's a lot of processing that happens at this stage where panels identify where they are and which panels are next to them. They communicate with each other. And the framing is allocated in a wireframe type format. Then we identify unique panels. There you can see the colors of the unique panels. And now we're extruding the profiles along the center lines. And that is only done for the unique panels, one master panel for each unique panel. And that just saves computation time. And yeah, really just is essential in all of this. The longest one is this one, profile, trim, and drill. It's mitering the panels of the framing where they come together. And then I cut the glass. And once all of that is done, I distribute master to slave, and you get the final curtain walls. We're then also able to use a Grasshopper script to do our elevation, section, and plan drawings. And that is quite simply done by creating, if you look on the left-hand side, there's a yellow box. There are 3 white boxes and 2 red boxes. And you just create those boxes, and with these sliders in Grasshopper, you can adjust their parameters. And then Grasshopper takes those boxes and isolates the curtain wall and structure within those boxes, and uses a component, a Grasshopper component called Make 2D, just to make a 2D drawing of that. And yeah, that's pretty much the process. Completed projects. The very first project we did after my imaginary little project was this one, Nexus 1 in Midrand. And just off the bat, I had a lot of things to update all of a sudden on a real project. It was scary. I had to be able to decide, tell the program whether there must be a male or female mullion on the end of a curtain wall, because we have different conditions. Sometimes you want a male mullion, sometimes female mullion, depending on the detail. We added fins to the curtain wall panels, to the mullions. You can see in this picture. And then also I added the ability to specify the glass thickness, or whether it's single or double glazing. And in a single glazing condition, the glass sits closer to the aluminum framing, and the front leg of the framing is cut off. So that's important to get right. Our next project was Terraco. That's a data center in Johannesburg. Here the improvements were that we've got 2 different mullions, a normal mullion and a deep mullion for double volume spans. So I added the ability to add those in. We also had single and double glazing, a mix of those. And so in a corner where single and double glazing meet, the gutter, I mentioned the gutter profile, that gets quite a complex mitre for that situation. So that ability was added in. I'm not going to go through all of the little nitty-gritty improvements we made. But the biggest one on this was that we need to bring in the structural components from the structural and architectural Revit models. And sometimes when those things aren't modeled neatly and properly, you end up with horrible shapes to work with. So I wrote a script that sort of cleans that up and creates solid objects that don't give us any issues. The next project was 110 Oxford in Johannesburg. Interesting thing here is that these beams and columns are really completely pseudo. They are aluminium panels that are just glazed into the unitized panels instead of glass. Then came River Club. This was the first project where we introduced a new profile into the system, a compensation channel, really a channel at the top of a system that the system sits in. And then we also had to be able to use that compensation channel. You'll see as a link bridge at the top of that. The architect wanted that comp channel used. So typically within the program, it scans for concrete, and where there's concrete, it adds the comp channel automatically. If there's not concrete, then it puts a gutter there. So now the software, you can specify I want a comp channel or I want a gutter. And then the hardest thing on this project was change management. All the previous projects were quite small. And so you could pretty much do the whole project in one go, submit all of the drawings in one go and get approval and move on. But on this project, much, much bigger, you'd have approval for some of the facade, but the architect is still designing the upper floors. And so then he makes a change, you change the model, as you run it, those unique IDs get allocated. And all of a sudden the draftsman says, but I've already got a U5 panel. Now I've got another U5 panel, what's going on? So that's a challenge that I'm still working on. But what we did is we simply gave the curtain walls a label, whether it's complete or incomplete. And if it is complete, then those unique IDs cannot be allocated to any of the other panels once the software runs. Also worked on GHO in Mauritius. The curtain walls were not the challenge on this one. Cladding and louvers were. Curtain walls were actually quite simple. That beehive you see there was by others. Then we did the Iris in Johannesburg and Black River Park in Cape Town. The refurbishment we've just finished. The interesting thing on this project is that we really used a bit of a hybrid between the 3D automation and the old conventional 2D way of doing things. When I looked at this project initially, I said, there's no way we can do this in the software, because the number of panel types that I have to allocate is the same as the number of panels in the project. There's nothing unique. But the reality is that the glass behind all of those aluminium ribbons are really quite similar. So there's a lot of repetition behind that. And then you've got these fancy aluminium panels that clip onto the unitized panel. And those are quite different. And so the panels are different in terms of where those brackets are on the mullions, where they hook onto. And this is a completed wannabe project. We worked on this for over a year. And it's also a refurbishment in Mauritius. I put it in here because my heart is still a bit sore, because we put a lot of hard work and innovation into this project. And after a year of letters of intent and the client ordering the glass, they decided to can the project. And then current projects, like I've shown you, Ingress Building 3, we're currently working on that. And the new feature on this one was it's the first project that we did with a slanted facade. You can see that middle facade is leaning outwards, so there were a few changes required for that. And then we're working on Compensation House in Pretoria. It's also a refurbishment. And the interesting thing on this one is that we're using two different facade systems. So what are the advantages of this process? You get a 3D visual model, so everyone can see in 3D what's going on, everyone on the professional team, and so hopefully that leads to better cooperation, and it has on most projects. We have centralized data. We have one model in which all of the data for the facade sits. Should lead to reduced errors, right? Hopefully. Faster drawing generation. I think that's obvious one. Now, the biggest one for me is to have an early foot in the door to initiate design change. And I've seen this so many times. You get the structural and architectural models, and within a week you're done. You're ready with the model. You can issue your elevation, section, plan drawings. Even if you're late on your details, you can issue those. And you can show them that model and identify clashes, even though the structural engineer may only have issued up to first or second floor for construction. And usually you would have to wait for that information to come through. Now we sort of forcing the process by saying, well, this is the information we have and we see a potential clash. And so that early foot in the door has really helped us on a number of projects. And then we've seen it as well, where you can finish all of your design before construction. Most projects run, you're still doing your design while the construction is taking place, but being able to separate that more. Terraco, for example, that data center that I showed you, we were done with all of the shop drawings, everything approved, maybe a month or two before construction, because I remember that they'd phoned me from site and I couldn't even remember because it was so long ago that we did the design. What are some of the disadvantages or challenges? On a project-by-project basis, you have to decide whether the programming effort that is required, is it really warranted? Perhaps it's quite a unique design and something that you think is not going to be repeated in future. So is it really worth updating the Grasshopper scripts to be able to accommodate anything fancy on that? Are there any non-unitized facade types? Because those are just not handled with this tool. And then training, it's hard to find time to, besides doing the work, to transfer skills. Because the idea really is for the drafting team to be handling this whole process, where at this stage I'm doing a lot of the modeling and then transitioning the drafting to the draftsman. Sometimes we do conventional ways. This is a project we recently completed that had a lot of different facade types. You can see some glass fins in the atrium. This western elevation, a lot of punch windows, so not that much in terms of curtain walls. So yeah, sometimes we go back and we do things in the 2D way. What are some future developments that I'm looking at? Biggest one is probably change management, like I pointed out on River Club. How do you manage a program or a project where part of it is approved and part of it is not? So yeah, that's an ongoing challenge. The import of structural and architectural models, it really depends on how the architect and structural engineer have modeled in Revit. Sometimes it's really easy. I create a material schedule, I select all concrete elements, export, and I've got all the concrete, same steel, brick, and so on. And sometimes it's just not modeled like that, and it's hard to go and pick out, and time consuming to go and pick out all of those components. And currently I'm identifying panel types manually. At the beginning, I have to see what panel types they are and create them. So I'm thinking in the future that there could be a more of an automated process for that. And then we don't have brackets in our system yet. So that would be a good addition. And then project challenges as they present themselves. So that's it. Thank you for listening. And I want to thank Kirsten and Horak Aluminium. They're the contractor who built all these buildings. And they're the guys who listened to me when I came to them in 2020 and said, I think you should consider doing things a little bit differently. So I thank them for their trust.
Thank you, Rudolf. That was very interesting. We
Thank you,
don't
Pierre.
have any questions from the floor, but looking at all the software that you've showcased today, I just see costs involved or software
Yes.
cost. Which of these apps are actually free and which are paid for, I guess?
Yeah. So Autodesk, you can get the AEC collection. It comes with Revit and AutoCAD and all that. That's quite expensive. That comes at an annual subscription cost. Rhino,
Yeah.
on the other hand, is a perpetual license. You buy it once and you have it forever. That's a lot cheaper. And then the plugin Grasshopper is free. That comes with Rhino. Elephant is, as up to now, it's been made completely available for free. Trying to think what. And then Tekla, I haven't used Tekla in many years. I understand that's also quite expensive.
Mm.
Yeah, so
I
this
know
process.
Revit and so on. Yeah, I know Revit and so on are very, very expensive software packages. Yeah.
So moving towards Rhino is also cheaper because you buy the software once. An upgrade might cost you 8,000 Rand. If you want to upgrade, you don't even have to upgrade. So yeah.
Okay. Jan, maybe any questions from your side?
Yeah, I've got more general questions. Rudolf, well, first question, you said you convinced the contractor to buy into the system and this approach. How
Yes.
difficult is that? Because it's a new way of doing it, providing a new vision. So, you know, what are the challenges and what would you recommend for anybody who wishes to go that way? So that's question one. Question two is you often mentioned the technician who did the CAD work. How difficult is it to find operators, technicians that work at that level?
Two difficult questions. Yeah, I think what really helped in my situation is that I had a very good working relationship with this contractor. So that, of course, is critical, first of all. And then speaking to the right person. The younger people are more inclined to listen to new ideas, and then gradually spread that to the rest of the team. If it wasn't for COVID lockdown, perhaps they would not have listened to me. So I have to thank COVID for that as well. And yeah, your question on draftsmen, it is very difficult to find good draftsmen. Yeah, we have, I don't want to count incorrectly, two really good draftsmen that are passionate about doing things doing things really well, doing things properly. I think that's the key, and yeah, I don't know. I have thought about what are we going to do into the future, because we have to train new people up, and I don't know where to start. Yeah.
We've got a question from Johan van der Merwe. I think it's also quite a tough one. I was reading today an article on how difficult it's becoming to do hand checks with the geometries that we work with. The question is, any advice on how to perform sanity checks, or what type of spot checks do you do?
Sure. Yeah. As far as BIM and facades is concerned, the spot checks that we do, they are so simple. Is to look at, we've got a spreadsheet with data output that tells us what the glass sizes are. So before ordering that, you look at a few of those, you look at your elevation drawings, and you double check that the dimensions make sense. Yeah, those are sort of the type of spot checks that we do. I'm trying to think if there's any. Yeah, there's some software applications that you can look at. You have to be clever, but let's say you're doing an area comparison of glass versus overall area. You can quite easily measure the area of the overall surface and then compare it to the sum of all of your glass areas, those sort of things. That's about all I can say about that.
Thanks, Rudolf. We don't have any further questions. So going.
I can ask a final one.
Rudolf,
some advice to if somebody else sits there thinking of starting his own practice for doing facade work as a consultant, as an advisor, what would be your advice?
You need good connections. You need to know people.
Physical connections or human connections?
Human connections. Definitely, you need to know people, and yeah, I I don't have much else to say about that, but yeah, I think that would be the one thing. If you don't know the right people, and you don't know, you don't trust, and you don't, I don't know how else I would have done it. Yeah.
Excellent, thanks.
You mentioned this contractor at the end of your presentation. It was Fierstein and somebody, I forget the name now. do you, as a facade designer, do you work for the contractors or do you work for the clients, or where do you fit in on the project?
So there's two roles that you can fulfill as a facade consultant or engineer. You can work for the client, and then you are on the professional team, just like your structural engineer, mechanical engineer, and so forth. And your role then is to come up with a facade specification. And on most projects, you would not really generate much in terms of drawings. You may do some sketches of critical design, critical interfaces. And yeah, so that would be the one role. And then the second role, which is much more what I've demonstrated today, is where you work as the detailed design engineer for the facade contractor. And so that is getting down to the nitty-gritty of every bracket, every interface, every waterproofing detail, making sure that all of those areas are covered completely.
Mm-hmm. Yeah, it's very interesting. Thanks very much, Rudolf. I think if there aren't any further questions, we can close this webinar. Okay. Thanks
Pierre.
very much. Much appreciated.